Buffers. Buffers are solutions that resist the change in pH upon adding an acidic or basic components. So proteins in our blood has a problem. They have to have a specific pH to ensure the normal functioning of its cells, like carrying oxygen and carbon dioxide. So our blood contains a buffer that allows it to maintain its pH, which is 7.35 to 7.45. So what is a pH level? pH level is used to specify the acidity or basicity of an aqueous solution. Lower pH value means solutions which are more acidic in nature, and higher value means solutions which are more basic or alkaline. So later in the video, I will give you some examples of acids and their pH levels. So there are two types of buffer. The first one is an acidic, which means a buffer that has a pH below 7, and the next one is alkaline, which is a buffer that has a pH above 7. So here are some examples of acids and their pH level. So as I've said before, an acid that has a pH below 7 is considered an acidic, and an acid that has a pH above 7 is considered an alkaline.
First step, select recipe from database. Second, recalculate recipe quantities according to the required buffer volume. Third, weigh compounds into the vessel. Weighing vessels should be chosen to protect the balance from corrosion. Balances are expensive and chemicals spilled on the balance may corrode the delicate mechanism, causing reading to be incorrect or preventing the balance from working at all. Fourth, dissolve the compounds in a suitable solvent. This is typically water. Water is described as a solvent because of its ability to solvate many but not all molecules. Fifth, check and adjust the pH value by using a pH meter. pH is a quantitative measure of the acidity or basicity of aqueous or other liquid solutions. In pure water, which is neutral, the concentration of the hydrogen ion is 10 raised to the power of -7 gram equivalents per liter, which corresponds to a pH of 7. A solution with a pH less than 7 is considered acidic. A solution with a pH greater than 7 is considered basic or alkaline. 6th, top up the solution to the required volume. 7th, transfer to a storage bottle and label. 8th, documents result. Laboratory documents provide the means to review laboratory activities. Excellent documentation is proof that experiment is accurate, precise, and reliable. Graduated cylinder, a common piece of laboratory equipment used to measure the volume of a liquid. Balance pan, it is a device for weighing, designed to measure small mass in the sub-milligram range. Its measuring pan is inside a transparent enclosure with doors so that dust does not collect and so any air currents in the room does not affect the balance's operation. Stir plate, a device widely used in laboratories and consists of a rotating magnet or a stationary electromagnet that creates a rotating field. This device is used to make a stir bar, immerse in a liquid, quickly spin or stirring or mixing a solution. Chemical weighing scale, used for determining the weight or mass of a sample. Scientific balances are among the more vital pieces of laboratory equipment. Lab scoop, used primarily in chemistry lab settings to transfer solids. With one pointed end and one blunt end, design allows for digging out and handling of small amounts of material. Weigh boats, used to weigh substance that will be transferred to another vessel as well as protect the scale tray. Weigh boats have smooth surface with rounded corners which allow controlled pouring of liquid, powdered, or granular samples. pH meter, an instrument used to measure acidity or alkalinity of a solution. pH is the unit of measure that describes the degree of acidity or alkalinity. Hydrochloric acid or muriatic acid. It is a strong acidic solution of the gas hydrogen chloride in water that can attack the skin over a wide composition range. Tris buffer, a common biological buffer used throughout the DNA extraction process. The first step is to add 210 ml of water to a 250 ml graduated cylinder. Transfer the water from the cylinder to a 600 ml beaker. Next, we need to weigh the tris. Place the weigh boat onto the balance pan and press the tare key. Use a lab scoop to add 15.14 grams of the powdered tris buffer. The measurement should be within plus or minus 0.02 grams. Next, we need to add the powder to our 600 ml beaker. Flick the weigh boat to your finger to add any remaining powder. Mix the solution until it looks completely clear. There should be no visible clumps of the powder in the beaker. 6. Watch the display and wait for the pH reading to stabilize. Add hydrochloric acid to get the desired pH. Remove the probe, rinse it with water, and place it back to the storage solution. Next, we need to bring the tris to the final volume of 250 ml. Use a second magnet under the beaker to hold the stir bar in place and slowly pour the buffer into the graduated cylinder. Add water till the volume is 250 ml. Transfer the tris buffer back into the beaker. Insert the pH meter probe and verify that the pH is still the same. Pour the buffer in a bottle and label it with the name of the solution, the pH, the date it was prepared, and your initials.
Tris is a buffer that's used to maintain a stable pH when working with solutions in the lab. In this exercise, we'll demonstrate the steps for preparing 250 milliliters of a 0.5 molar Tris buffer. The first step is to add approximately 210 milliliters of water to a 250 milliliter graduated cylinder. Transfer the water from the cylinder to a 600 milliliter beaker. Add a stir bar and place the beaker onto the stir plate. Next, we need to weigh out the tris. Place the weigh boat onto the balance pan and press the tare key. Use a lab scoop to add 15.14 grams of the powdered tris buffer. The measurement should be within plus or minus 0.02 grams. Next, we need to add the powder to our 600 milliliter beaker. Flick the weigh boat with your finger to add any remaining powder. Mix the solution until it looks completely clear. There should be no visible clumps of powder in the beaker. Now we need to adjust the pH of our tris buffer to reach our target pH of 7.8. Insert the pH meter probe into the solution. Be sure that you don't put the probe in too deeply, because you don't want the stir bar to come into contact and damage the glass electrode. Watch the display and wait for the pH reading to stabilize. The current pH of the tris is 8.86. We need to add hydrochloric acid to lower the pH to 7.8. Add a couple of drops into the beaker. Wait for the pH to stabilize. Now add a few more drops of hydrochloric acid until you reach the target pH of 7.8. Remove the probe, rinse it with water, and place it back into the storage solution. Next, we need to bring the tris to the final volume of 250 milliliters. Use a second magnet under the beaker to hold the stir bar in place and slowly pour the buffer into the graduated cylinder. Add distilled water and look at the meniscus to bring the final volume to 250 milliliters. Transfer the tris buffer back into the beaker. Insert the pH meter probe and verify that the pH is still 7.8. Pour the buffer into a bottle and label it with the name of the solution, the pH, the date it was prepared, and your initials. Now our tris buffer is ready to be sterilized in the autoclave.